All right, so hello everyone, and thanks for joining to our tutorial on automated benchmarking of cloud-hosted database management systems with benchANT. The tutorial is gonna be held by my colleague Jörg Domaschka and myself. A bit of background for both of us so that you know who's talking to you today. We're both researchers at the Ulm University in Germany, so southern Germany. And we're both co-founders of benchANT. As you can see, we both have a research background in computer science and distributed systems, database systems, cloud computing. And in today's tutorial, we basically will cover 5 parts. So we're going to start with the concepts on scientific results behind benchANT. Second part going to be a live walkthrough through the platform. Part 3 going to be a hands-on session where you can actually try out benchANT yourself. The fourth part going to be some discussion on results that we gathered in case studies that we carried out with benchANT, and concluding with an outlook and also discussing potential data challenge for the next ICPE. And having that said, let's start with the first part, the concepts and scientific results behind benchANT. And in order to start into that topic, I will briefly go over the advances of data management technologies for data-intensive applications, and especially their evolvement over the last decade, which was quite a huge advances when it comes to, first of all, the types of database systems. So relational database systems are not the only choice anymore. There are many more that can be classified in NoSQL and NewSQL database systems. And when it comes to the operation of these database systems, so physical resources are not the preferred choice anymore, but we have now a set of elastic resources, cloud resources, edge and fog resources that are used to operate these systems. And with that change, there are basically 2 things that have significantly changed. So as already said, cloud resources are nowadays the preferred solution to operate database systems. And the idea of one size fits all is over for just choosing one database system and that's gonna be the one solution is not the case anymore. And with that change, also, the decision making or the selection of the right solution has significantly changed. Because nowadays, of course, performance and costs are the important drivers of these decision process, but also additional objectives such as scalability, elasticity, and availability become even more important. And so this decision process or this decision making has changed. While we had in the past, database systems were sold as appliances together with the hardware. There was more or less clear landscape of the relational database systems, and we had lasting benchmark results at least. So thinking about the TPC, the huge tables with the TPC results, for example. And nowadays, we have a plethora of cloud and database technologies out there. Both technologies are rapidly evolving. We have the option of the polyglot persistence. And there are, of course, benchmarks results out there, but due to the huge space of potential combinations and also the rapidly evolving technologies, it's barely possible to keep these benchmarking data up to date. And that's also how this the whole benchmarking process changed over the last decade. So back in the pre-cloud era, database system and the hardware together were basically static components. Of course, you need to select and configure the right benchmark for your target application, executing the benchmark and processing the objective, the results, which were basically costs and performance. Nowadays, this whole process is in the cloud era is way more dynamic. As already said, we have this rapidly evolving cloud market. We have the database systems that are still new database systems are popping up on the landscape. And we also have the focus on more objectives besides cost and performance, so scalability, elasticity, availability. And of course, this all needs to be considered in this whole benchmarking process, which then extends this process to additional steps that make the process itself more complex, and also increases the dimension that needs to be considered when running benchmarks, and how to include that in the results, or how to consider that in the results. And we're gonna come back to that later on. And so let's see what the current state of the art is when it comes to database benchmarking, and this in respect of this process. So we have a tremendous amount of different kind of well-established benchmarks when it comes to database benchmarking. So they're covering diverse domains from the OLTP, HTAP, and OLAP workload domains. They're going to provide you extensive performance metrics, and also a set of database evaluation principles has been established by the performance engineering community. But if we look at the whole process, what we're currently missing is how to actually consider the elastic resource characteristics in the whole process, and also in the result processing. It's also hard to consider or to estimate how the aspects of a distributed database systems come into the process, and also how they're gonna affect the results, because each database system has their own distribution configurations, and how to compare then different systems in a fair manner. It's very challenging. Of course, this whole process includes several steps on different technology domains, so allocating the resources, configuring the database system, running the benchmarks, and processing the results. And as already said, so existing benchmarks, database benchmarks, provide you extensive performance metrics, but for the higher level objectives, when it comes to scalability or elasticity and availability, there's only limited support so far available. And when we now look at the options how to operate the database system, we have basically three pillars. So we can operate on-premise, either bare metal or a different type of virtualization container virtual machines. We can operate it as a self-managed database system in the cloud, on infrastructure as a service, again, on virtual machines or containers, or we can buy the fully managed service, the database as a service in the cloud. And of course, to the right side, you will get way more operational simplicity, but you will lose the control, of course. And it is very hard to estimate what is actually the trade-off between performance and costs for a specific database system. And that's also something that we're gonna address later on in the tutorial, and demonstrate you how with the benchANT, how you can use the benchANT platform to actually find out this performance versus cost ratio on these different scenarios. So for on-premise installation, for self-managed in the cloud, or for database as a service systems. But before coming to that, I will briefly go just over the term polyglot persistence that I mentioned earlier and the different database technologies. Just a few a brief overview. So we have the relational systems, we have the NoSQL systems, and we also have the new SQL system, which are basically extending the relational systems, but with the focus on the distributed architecture and to support horizontal scalability and also elasticity. Right now we have more or less over 700 database systems out there, of course, in different maturity states, so to say. And all of them gonna provide you performance, high scalability, elasticity, and availability. But what we're gonna see also later on, there are, of course, significant differences between their performance and scalability, elasticity capabilities. And in order to find out these trade-offs or these differences, it's also the case that basically all big players on the cloud and database market, they highly recommend to do extensive benchmarking. But what they're actually not provide you is a tool support that where you just can run these benchmarks in an easy and on-demand manner. So that's always up to you. And running significant benchmarks or reproducible benchmarks, it's a challenging task. And that's also why we came up with the first of all, with the research ideas to build an automation tool for database benchmarking in the cloud, and then also build the benchANT on top of it. And the goal is to fully automate the benchmarking process in the cloud era. So automating all these steps from allocating the resources, deploying, configuring the cluster, selecting and configuring the benchmark, executing the workload, taking care of the resources, and processing the different kind of evaluation objectives in a fully automated manner. And so that's actually how we came to the part for the need for automated database benchmarking. And as already said, there are, of course, tools out there that really support the individual tasks in this whole process. So we have for the cloud automation parts, there are several tools out there. Then we have, of course, the benchmarks from the database research community and also from industrial aspects. And of course, there are a lot of tools for processing and visualizing the results. And there are also first approaches to bring that all together in one end-to-end platform. So we have, for example, MongoDB that also presented their results during the last editions of the ICCPE, where they build an end-to-end performance testing platform that they use internally. ScyllaDB follows a similar approach. There are also benchmarking frameworks or evaluation frameworks such as FlexiBench that are aiming in this end-to-end automation. Then we have the Mowgli framework, which is a research result by our institute, and this is it was presented during the ICP 2019. That also addresses the end-to-end automation of the benchmarking process, and the Mowgli framework is the technical and scientific foundation of the benchANT platform that we're going to see later on. Just as a brief overview on the Mowgli framework. So the tool itself, it's available in the SPEC research repository, and there are basically three pillars. So Mowgli defines an evaluation specification where all the required properties can be configured to automate the benchmark process, so the required resources, the database system, and the desired workload. Then there's an evaluation execution part that does all the steps, and that executes all the steps. And there is also an automated processing for different kinds of results included. And yeah, with the Mowgli framework, we already ended up with a rather huge distributed system in order to automate all these outlined tasks. And we took this this framework and extended it with an evaluation designer, so a graphical user interface to actually ease the configuration of different kind of benchmarks. This is also something that Jörg is gonna demonstrate later on. Then, of course, we extended the internal framework with a lot of features, but the concepts are based on the Mowgli framework. And we also built a powerful interactive analytics dashboard in order to analyze the results on different levels. And just some details on what Mowgli can actually automate, and vice versa, of course, what benchANT can be used later on. So as already said, performance is one key objective, but also, of course, scalability. So comparing the performance of different cluster sizes in order to analyze the scalability, the horizontal scalability of a database system. The second objective that is also tackled by Mowgli and in the future also with benchANT is elasticity. So what actually happens if I scale my database system at runtime in order to address workload fluctuations. Here, the framework is able to automatically adapt either the database cluster at runtime, but also to adapt the workload at runtime in order to emulate workload fluctuations over time. And the fourth objective is availability that is tackled by Mowgli and benchANT. So what does how does the database system behave or respond if a node fails during runtime? And in order to evaluate that from a client and a server perspective, our framework is capable of injecting failures during the benchmark process. So these failures can be either resource failures or failures on the database level. And yeah, the whole system is monitored, and we also defined a set of availability metrics that can be found in the respective papers. And with this, with this automation platform, we can now address several use cases along the DevOps cycle. So, for example, when it comes to starting a greenfield project and finding the optimal cloud provider and database system for a use case, but also during the capacity planning phase, the framework can be applied to do load and stress testing, but also to evaluate the scalability and elasticity of the system under different conditions. It can also be used for application-specific performance optimization, as of course there are a lot of knobs and bolts to tune your database system, and these can all be easily experimentally evaluated in order to find out which performance knob you should tune for what kind of workload. And the framework can also be applied to keep track of the continuously evolving landscape of database systems, but also of different kind of database versions, as it's rather easy to run large-scale benchmarking studies for different versions of one system. And this is also something that we're gonna now just provide you some very high-level insights, what can be done with the benchANT framework, before later on we're gonna, in the next parts of the tutorial, we go into more details. But I will briefly go over some case study insights that we already executed with the framework.
Can I ask a quick question?
Yeah, sure.
As you may know, we also do quite a bit of benchmarking work, and one thing that I wonder is how modular is the system? Because my feeling is a lot of customers are not gonna want or need all of these components. Especially when I look at analytics, I think a lot of researchers like to do their own analytics, whereas this might not be so true for commercial customers. Whereas commercial customers probably want very specific control over how the whole thing is configured, but then want the analytics. So how modular is it? Do I need to use all of it, or can I use, you know, the analytics and the execution, but not the rest, for instance?
Okay. So first of all, the modularity of the system was one of the key aspects when we built it, but more with respect to having it very modular to integrate new resources, so new cloud providers, new database systems, or also new analytical steps. So this is very easy with the framework right now. So including a new cloud provider in the is maybe one day work. But when it comes to executing the framework, then it's not that modular anymore. So you can't just use the processing. That's right now not possible, while it would be on a technical level also not that tricky to just slice out the respective parts. But for now, it's you have to use the whole platform. But as you said, customers might want to have the full control or full transparency and so on. That's also something that we, of course, had in mind, as we provide all the data or expose all the data to ensure full transparency, or also some kind of audit. And that is something that is Jörg later on showing in the dashboard that we talked about. So in the end, for in order to ensure transparency, but also reproducibility, which was also one of the key aspects more from the research side, we want to expose all details that you basically could run the same benchmark by yourself if you just set it up everything by yourself. So there shouldn't be any black box magic thing in between that no one knows about. So that's the goal of the framework.
Thank you.
Yeah, sure. So just some insights in the case studies that we did. In one case study, we wanted to not demonstrate, but we were curious what is the actual difference between if you use different cloud providers, you use the same resource dimensions for a virtual machine to operate your database system. So for that, we use rather small instances with 2 cores, 8 GB of RAM, and the cheapest available storage option to operate a 3-node MongoDB cluster. We did that on 3 cloud providers, so AWS, the German Telecom, and Ionos, another German or European cloud provider, with 1 workload specification. And then we applied a score for the 4 KPIs: throughput, write latency, read latency, and cloud costs. And then it turned out that the results are quite heterogeneous between the different cloud providers. It was interesting. On AWS, you more or less get what you pay for on a more linear level, while for the smaller cloud providers, it was very heterogeneous. As you can see with the different shapes here, we will look into these numbers later on in a bit more detail. Yeah, what we could also find out, which was quite interesting, that choosing the SSDs over HDDs for good write performance is not necessarily true for all cloud providers, which was quite interesting. I can also go into details why that was the case later on. We also did version benchmarking of different database systems. So, for example, we benchmarked different versions of Cassandra to show how the if the performance increased over time with newer releases. We also did the same for MongoDB. And yeah, but as already said, these are just some insights in case studies that we did, and we will have a look at the numbers later on in more detail. That was just yeah, a small teaser what's going to be demonstrated in the following part. So this was basically the intro, or the first part on the scientific scientific background and concepts of the benchANT platform. So if there are already any questions regarding the right now presented details, I'm happy to answer them right now. And if that's not the case, then we can also
I'm searching to find the source code. Is it available or not?
For the framework, or for you mean the data?
For the framework.
So the Mowgli framework, this is available as open source. It's also available in the spec research group tools repository. But the benchANT platform itself, this source code is not available. It's only as a service available. Yeah. When it comes to the data, we are happy to, or would be happy to share data if it's for research purposes. So that's also possible. Yeah, I think Jörg will also talk about that later on. Yeah, but so the source code of benchANT, that's only available as a service platform. Yeah.
Mm-hmm. Thanks.
Okay, so then I'm gonna hand over to Jörg, who will provide you, yeah, a live demo of the benchANT platform.
Okay, thank you, Daniel. Just in time, 30 minutes as planned. Great. Okay, let's see if I can do the same. So, as Daniel said, I will do a brief tour over the platform before we then can dive into some hands-on parts. As I said, this is just like the high-level overview of the functionality. So once you have access to our platform by just signing up and getting an account there, you will be faced with what we call the central dashboard of the platform. As you see here, we have a couple of benchmarking projects already available. Most of them are from some studies we did, particular for some white papers that we wrote. I also created a new project for the ICP, and now let's just dive in how that works with configuring the different scenarios. As Daniel said, we basically have 3 domains where we want to configure settings and compare settings. One is the database domain, the other is the cloud domain, and the third part is necessarily the workload domain. So the configurator that we build tackles all of these 3 parts. Daniel also mentioned that we do benchmark, or we are able to benchmark database as a service systems. This is the case for the backend of our platform, but the configurator as of now does not support that. We're currently working on integrating that functionality in the user interface. So as said, we have to like define database systems. We want to compare cloud providers and workloads. And let's start with the database part. So here we have a set of databases available, database systems available, ranging from document-oriented down to relational databases, but also some not so well categorizable things such as Redis. Let's start with Postgres maybe and pick a new version. And as Postgres per se is not like cannot be clustered, the cluster size here is necessarily 1, and also as we have only one instance, we also have a replication level of 1. We have currently not the capabilities to specify any database specific configurations. Again, this is possible in the backend, but we're working on integrating that in the front end. We can save that configuration, and maybe let's add a further one. David is not here today, but let's go for MongoDB. Pick a new version, and here you can see MongoDB can be run clustered, so we can select a cluster size. The settings go up to 9. MongoDB just recommends using a cluster size of 3, and they also recommend always using a full replication. That is, we also would go for a replication degree of 3. Then we have a couple of configuration options we can provide for MongoDB. One is the memory ratio that should be used. That is the amount of memory of the end of the node to be used for the database. Then we have, that's general, that's a setting that we use. And then we have MongoDB settings such as the oplog size, which is here also 5% of the available storage. Because of the version that we selected, 5.05, there's only one storage engine available, and also MongoDB suggests using journaling in that version. So this is enabled, so we can set that here and again save that configuration.
Jörg, quick question. So how do you decide which configurations you surface in that way? Because presumably there's a lot more you could configure, right?
Absolutely, absolutely. What we it's basically based on needs. Currently, as I said, we have the version set in the back end and the front end. Back end can do a lot of more things than the front end can, because it's always very not difficult, but time consuming to implement that in the front end. We have so far decided on whenever we run a study or we run a scenario for either research cases or for customers, then we added these configuration options that were needed. You're right. There is a tremendous amount of different options that are available. Like I really don't know the exact numbers. Daniel knows them better, but 20 is on the lower end of the spectrum, and some databases have more than like 100 knobs where you can tweak. So this is definitely only a subset available of the full space. And we hope that by finding a couple of more developers, we will be able to cover that more exhaustively. But currently, we have to live with the subset. Same goes for the cloud domain, where we have, as said, currently the infrastructure as a service resources available. Obviously, AWS and Azure. Unfortunately, Google is missing here. Don't know why. And we also have a couple of German cloud providers, Jonas and German Telekom, and we have our private cloud system that we have at the university also integrated here. And yeah, let's go with AWS. First select the cloud provider, then select the region, and then as we have a big package enabled or big project enabled for this demo, there's a lot of different flavors to select from. Let's just pick one where we have like between 8 and 12 cores, and we have something between, yeah, 8. Okay, let's pick that, C2X large. And then you would usually also have different storage types available. As also Daniel said, that's something to configure. Backend can again do more here than the front end. In the front end, we have only GP2 for AWS. Okay, then the process is the same for other configurations. Basically, you can select from all different virtual machine flavors and all the storage types available. And once you're done with that, we can turn into the workload configuration. Here we have decided to integrate several benchmark suits. One of them is the YCSB, Yahoo Cloud Serving Benchmark, which is very often used, not only in academia, but also by different database providers. And we have also started now integrating other benchmarks, in particular from the TPC domain for the relational databases. Let's stick with the YCSB because that's fully integrated. The TPCC is not fully integrated yet. So what we see here is different predefined workloads. These come from YCSB itself. So they have a couple of different preset configurations, but we can also try to go for a custom configuration where we can define a number of parameters, such as the number of records we want to use, the read-write ratio, the size of individual records, but also the number of workers that, or the clients, or whatever we want to call that, that issue the load, and of course the workload distribution. So these are, again, as with the database parts, these are parameters specified by the YCSB, and we just pick the set and are basically done, unless we want to. Maybe we can add another one. Let's say we want to have an IoT workload, which is, as you see here, predefined, has a very high write part and very few read operations. Okay, now we're done with that. Sorry, my screen just switched off. Just a second. Good. Now we're done with that. And now what the tool does, or what the platform does, it calculates the cross product of all the configurations that we have. So we see so we have selected 2 database systems, 1 cloud configuration, and 2 workloads. So we now end up with 4 configurations. Here's the 2 Postgres instances with the YCSB in the different workloads. And we have the 2 MongoDB instances again with the 2 different workloads. Then we can validate the project and then continue to checking out. That's where once that's completed, the platform would then start running in the background and would acquire cloud resources, run the benchmarks, collect the results, and process the results and produce all the nice graphs and tables that Daniel did show earlier. And now let's dive very quickly into how that would look like. Of course, it takes some time until the benchmarks are running. So let's pick one of the results that are already available. Here we have this dashboard with a study that we did for a white paper, where we wanted to analyze the performance of different cloud providers, different cloud setups with the same database configuration. So you see here, the database part is always a MongoDB version 4.4.2 with 3 nodes and a replication factor of 3. And the cloud providers differ, and the benchmark is always 80% write, 20% read with a Zipfian distribution, and again, YCSB. And Daniel already sketched that part in his slide. So we can see that the results are very different. This flavor here, or this configuration, seems to be very good. That one is also very good, but just more expensive than that one. Others look different, so we see a wide spread on different capabilities and different and suitabilities of the different flavors for that workload. Then we have the results also split up in different KPIs or different performance metrics, such as throughput. We have the costs, and we have also throughput per cost ratio. And you can see here that actually the smaller cloud providers are not that bad. So if you add more AWS performance metrics, they would basically be all on that very same line between like 25 ops per euro, whereas for the smaller cloud providers, you have a lot more fluctuation, and it's better possible to find a sweet spot here. Then we also have further KPIs with respect to latency, average latency, and of course percentiles. And the same goes for read latency. Now, let's see if that's working. If that's not enough, you can also dive deeper into individual traces, individual plots. For each configuration, we do 3 runs. And if the runs are sufficiently similar, we stop here. If there is a huge divergence between runs, then we add more runs so that we end up with something that's statistically sound. And if that's still not enough, you can even dive a lot deeper now and see and look at the individual metadata of the individual runs. You can get information on the cloud providers. You can get information on the VMs. You can get information on the database, in that case, MongoDB. And you can also get the YCSB metadata to reproduce the results by hand, should you want to do that. So that concludes the first part of the demo, I would say.
Quick question before you go on. So what does a customer actually get? So you showed the configuration, which looks really nice, and then you can order this. And if I saw it correctly, it's about $10,000 or so that this configuration costs. So what do I actually get for this $10,000? So is this one execution? Is this kind of is this like a measurement over time, or what is actually included in the product that your company is offering?
Yeah, okay. You're right. The largest bundle is 10,000 euros. At least that's our first estimate. We're currently working with some business development people on the right pricing. What you get for that, or each bundle consists. Let me start with that. Each bundle consists of up to 100 benchmarks that you can.
Okay, so the $10,000 is a subscription. It's not a price for a benchmark, because I thought, since you kind of clicked it together and then the price showed up, I kind of thought that this is a per benchmark kind of pricing.
No, it's the price for 100 benchmarks. So okay. One benchmark is $100 or euros.
So it's a subscription model essentially.
Sort of, yes. Okay. Exactly. And depending on what kind of package you buy, what kind of subscription you have, there are different features available in the package. So if you have a smaller feature, you will see less cloud flavors because the larger ones cost more. So we have to calculate our own costs and so on. So all these like 32 cores VMs will not be available in the smaller bundles. Also, the cluster sizes you can choose for the database systems will be smaller if you choose a smaller bundle, and so on.
Okay.
Right. Dan, help me out. What is next?
Next would be the hands-on session.
Okay. As we are only very short group of people, my question. So what I had in mind for doing the hands-on part is that everyone gets an account on the platform and configures a couple of setups they want to benchmark against each other. And as we cannot wait until that benchmarking is done, Daniel would then do a more detailed or in-depth tour over the results, showing some interesting findings that we currently have. So maybe let me just share my other screen then. Can only take forever. Right. Let's go with that. Okay, as I said, I had actually planned to do a different hands-on session, but we had severe technical issues over the last week that needed a lot of attention. So I was not able to prepare everything as I wanted to. So what I can suggest now is that we do really a hands-on on that platform, where you would first register and sign up using a valid email address. That's important because otherwise you will not be able to third step verify that email address, and then you would not be able to run a benchmarking project. Yes, so, and once you have valid verified email address, you can either try a free benchmark by start benchmarking here, or you can select a new project with new benchmark. We will keep ICPE related accounts for 6 weeks and delete them afterwards. And if you go for the new benchmark, you can, as Philip said, select between 3 different bundles, and the largest bundle is very expensive. But of course, we will not charge you for the sake of that demo. So whenever you either put a project name that refers to ICPE, or you put a billing address that refers to ICPE, we will ignore that bill or ignore that and will not charge you for that. So that's the initial step. And once you're done with that, you can just start running the configurator as I showed earlier, and then proceed to the checkout afterwards. As said, just put somewhere that this is related to ICPE, and we will not charge for that. We will also run up to 250 setups that come from all the participants, and we will also share the results once they are available. Exactly. So I'll leave it to you to decide if you want to do the hands-on process now. And
I tried to, but unfortunately I got an error when I tried to register.
You got an error when you did, okay, that's a good. I did rerun the registration today twice to make sure that there's no problem left, but okay.
You can try again, but it had a very briefly an error popped up, and then the window was gone, so I couldn't really see what the error was, but I can try again.
Did you get an email, Philip? Sorry? Did you get an email from the system?
Not yet, at least.
Because I got all the mails that we send out also come to me, and I got an email for you. Philip Leitner at Kalmas SE, right? That's
yes.
The email used for registering.
Yeah. says an unexpected error has occurred. And then it forwards into a window that looks like, now I got an email anyway.
Okay, 2 other people did sign up, I see. Ram,
yeah,
you also signed up. Did you also have problems or did it work for you?
It worked for me. I'm able to log in and then see the start new benchmark page.
Okay, cool.
Yeah, for now it also works.
No problem creating an account, confirming and setting a password. All good. Thank you.
Okay, Nuba, I guess that's you. You're very, the volume is very low. I can't barely hear you.
Yeah, I mean, it was all good here. No problem. Thank you.
Okay, cool. So Philip, you could log in now as well.
Yes, I'm now trying to create a new benchmark.
Okay.
So which one should I choose, you said?
The project, you mean?
Yeah, so it says Start Enterprise Premium.
Yeah, you can take the big bundle.
Okay.
Okay, then I suggest we leave you a couple of minutes. We're of course here for questions, but try the system out yourself, and we're looking forward to your feedback. Dan, are you here? Because I need to refill my tea for my throat.
Yeah, sure. I'm gonna be here if there are any questions.
Thanks, it was great.
Thanks.
Hey, any recommendation on like what I should try? I joined a bit late, so I might have lost some context. If I try new benchmark, what would you recommend?
Depends if you do you want to compare different cloud providers or different database systems. So that's gonna be more or less the first question. So if you want to compare, for example, the performance of different cloud resources, you could select Azure and AWS, then select similar sizes and just operate MongoDB on them to see how the performance.
Got it.
All right.
So first option is which database, and then I select which cloud provider. Am I right?
Yeah.
Okay.
Daniel, may I ask a quick question? I was looking at these interesting blog posts. I found them very interesting. Where can I find some more information about the algorithmic part of it, about the optimization algorithm you use?
So for which part are you referring? So the blog post, which one did you mean?
I mean for the benchmark, basically, I presume you have an algorithm that optimizes configuration, right? I was wondering where can I find information about the algorithmic aspect of the framework?
Okay. So the papers are basically all related to the concepts are related to the Mowgli paper and the follow-up papers. But when it comes to the configuration optimization, there we don't apply, for now, we don't apply an auto-tuning algorithm yet. So that's something that we have on the roadmap for more the research direction. Did also a bit of work in that area. We have one paper, the Baloo paper. I can share you that with you. This is when it comes to the performance modeling, performance prediction. And yeah, but we don't have a fully auto-tune optimization auto-tuner in place now. That's for a longer shot and also research related tasks that we're currently pursuing.
Great.
So your work, as you presented during the spec meetings, would also has a significant overlap in that area. So we can also, of course, discuss potential collaborations in that area.
Discuss if your company is also interested in research, I would love to discuss some research ideas.
Yeah, definitely. Because I also, when I read your paper that you shared there during the meetings, so we basically have the same data that you need for your optimization on the cloud and database level. So it really sounds like a perfect fit to have automated database configuration tuning.
There is also one other thing. I have a friend and colleague, Luigi. He's a professor at ETH, and he recently started a company, very similar company, doing database optimization. I wanted to connect you to each other if you already don't know each other.
No, that'd be great. Because so far we only knew about the AutoTune company or the spin-off from the Carnegie Mellon University. Well, they have this auto-tuning focus for relational database systems. So not necessarily the distributed systems and not with the cloud context, but purely the relational database systems. But also a related part. And it would be great if you could connect us with the Luigi.
Yeah, definitely. Definitely. He was at the Stanford. Actually knew him several years ago when I was at Imperial College. He's doing very great work in this area. I will connect you too.
Yeah, thanks. That's cool. Yeah, so we haven't or for now we don't give up the research work completely, but of course with a limited time, but there's still with this product there is also research still required to evolve it.
Awesome. Yeah, it's great work.
So I managed to do my benchmark, but how do I now check out? Because I tried to put in some dummy stuff for the checkout part, and now it tells me I have stolen. I tried to log in with a stolen token, and I cannot proceed.
Oh, okay. So.
And also the error went away too quickly. Otherwise, I would have screenshotted it. But
okay, I see our front-end developer likes to just to flash the.
Yeah, maybe he should increase the timeout a little bit on some of these errors.
No timeout, no error. That's now actually a good question for Jörg as soon as he's back. Because in my last test runs, there didn't. Or I never got that kind of error. So
I managed to screenshot it now. I can post in Slack. I cannot really check out right now.
For all the other guys, did you already check out and did it work for you?
So as he said, it was throwing error, but what I did is I put some dummy address, but in the name I put spec, but otherwise I typed in some dummy address, it went through.
Okay.
So yeah, I don't know if I need to enter something different in the billing address, or if I need a different browser. But
no, is it all the red error? Is it gone in the address fields for you?
no, so this is the error I get now when I click on buy and start benchmarking, and I haven't really figured out how to make it go away.
So hopefully you're gonna have the hint for that.
So what's the error you're getting? Is there a message?
Yeah, I posted on Slack. It says user with ID, some UUID, an IP address, my IP address, try to log in with stolen JVD token with IP.
Oh, something
So
maybe.
maybe my IP address has changed in the meantime for some reason. I'm not sure why that would happen, but apparently there is there's some validation on it.
Okay, yeah, that looks like the IP address changed somehow.
Okay, so I'm a bit surprised by that, but can't say it's not possible. Maybe it's possible. So maybe I try to log out and log in again. I don't know.
Yeah, that should help. Jörg, did you get the last part?
Just that there are again problems, which is not good.
And now I can't log in with my email address again.
Good. One step further. That's why we have the alpha signature, as there might be errors at some point in time.
Okay, so I've now figured out it logs me in anyway when I have this error.
Okay, so somehow the system doesn't like you, Philip.
No.
And you don't even have special characters in your name. So.
Does it validate the billing address somehow, or can I put in whatever here?
No, you can't just, there's no validation involved. Well, our business guy does the validation, but I told him to ignore everything that comes in today.
Okay. Yeah, now it worked. Now I have apparently started a benchmark, maybe.
Yep, I got the confirmation that you triggered something. Yeah.
But when I now click on see results, it says we are very sorry, the provided user ID and project ID do not match any results.
Yeah, that means that there are no results available yet. So
okay.
benchmark is now progressing, and once it's available, you will be able to click on see results, and it will hopefully just work.
There will also be email notification as soon as they're done.
Yeah.
By the way, I figured out why I had problems before. So apparently your email address validation is case sensitive, and it added a capital P at the beginning of my email address.
Okay.
Maybe don't make it case sensitive. It's what I tell my people in my web engineering course normally. Cool.
Okay. So should we go on to have some look at some more results, or are you still doing the benchmark configuration, guys?
I'm done.
All right.
Yeah, I submitted one like for MongoDB. I'm waiting for the result.
Okay, perfect.
Typically, how much time it takes?
Depends a bit on how many configurations did you specify?
One configuration with 2 cloud, MongoDB with AWS and Azure.
Okay, yeah. So as mentioned in the beginning, each configuration is executed at least 3 times.
Okay.
And the benchmarks are currently configured to fill the database with, I think in these configurations, it's with 20 GB of data, and then they're going to be half an hour the execution of the actual workload.
Okay.
So yeah, gonna take some time, but you will get an email as soon as they're done.
Yeah, makes sense.
Usually we also do a manual check before we send it out, because as said, we are in an alpha stage, so I want to avoid that we send out invalid results or garbage results. So usually once the system is done, we do a manual check here and only then unlock it. So I would assume that, well, tomorrow we should be able to send that out, or to validate and then send it out.
Yeah, not a problem.
Okay, Daniel, then I hand back to you.
Yep. All right. So just share screen again. Okay. So as Jörg already said, for this part, now we can go in more, looking into more details of the case studies that we carried out so far. So there are different kind of case studies. So we had this performance comparison of different cloud providers. We also did the version benchmarking of different database systems. So we did that for Couchbase, we did that for MongoDB, we did it also for Cassandra. And we also have a case study where we benchmark the performance of ARM-based CPUs versus the regular x86-64 architecture. Are there from your side any specific interests of any of these results that I should dive into?
I'm interested on the ARM versus x86.
Okay. So then let's have a look at these results.
Is it on a specific provider or across provider?
It was on AWS.
AWS, okay.
Yeah, AWS, but I see that there are not all results in there.
Okay.
So we might go to some other results. So there are only 2 results available. But if you're interested in these results anyway, we have a blog, and on that blog post you can you're gonna find 2 articles on the ARM results.
Oh, okay, fantastic.
I'll post it in the Slack channel maybe.
Yeah.
Okay. All right. Thanks.
Is your blog all in German or is it?
It's also English. It's just because of my browser, the default setting of my browser language. So.
Okay, so this is auto-translated.
Yeah.
No, not auto-translated.
Okay, so it's internationalized.
Exactly. Yeah. So. Yeah, you're gonna post the articles there, and then feel free to go through them. And yeah, if there are any questions, you can also, of course, come back to us. So what we can look at is, I mentioned that we did this comparison of different cloud providers, same resource sizes, for operating a MongoDB. And here, these are basically the results. And yeah, we have this. Okay, wasn't to us. We have this benchANT score, which combines the KPIs, throughput, read latency, write latency, and costs into one unified score. And for this case study, it turned out that this telecom flavor is actually the best, as with the highest score. And if we look into these radar charts with each score individually on one axis, so of course, as it is a score, the higher the better. So meaning higher score in costs means it's cheaper. High score in latency means low latency. And here it turns out that, as you can already see, it's very heterogeneous across the cloud providers. So the virtual machine flavors that we used were, you can go up again. So for EC2, it was the M5 large. For the telecom, you can find these here. For the IONOS, there were basically, they distinguish between AMD based and Intel Xeon based processor types. And this is the overview on the total throughput that can be achieved. So we see also that even the highest throughput was 11,000 ops per second with that telecom flavor. Lowest score or lowest throughput was achieved by this IONOS AMD based flavor with only 4,300 ops. Also, the costs are rather heterogeneous. So IONOS most expensive ones, but the AMD ones are the cheapest ones against by IONOS. When it comes to the latency, there is also nothing that surprising. So the AMD instances were the highest latency, telecom ones the lowest ones, together with this IONOS one. It was interesting for the read latency that these telecom instances had a really high read latency compared to the others. So also, if we look at the latencies, the percentiles of the latencies, this was rather interesting. But as we carried out these benchmarks several times, so several executions, and it was always the case. We also asked the telecom guys about that, but so far we didn't get any answer on that.
So normally when you see these big differences, there's always some sort of misconfiguration going on. So I think if your business starts exploding and you publish this kind of data more widely, then telecom will come out with a fix fairly quickly. or tell you how you need to change your benchmark so that it fits the system better. Because this big difference looks like there is something going on there, right?
Actually, yes, and we were hoping for some answers from the telecom with these results, but so far that didn't happen. So,
So are there plans that you can specify, or that you can somehow provide your own kind of workloads or your own kind of benchmark configurations? Because I feel if I run a company, that's probably the first thing I'm going to ask for.
Right? Definitely. So there also, when it comes to integrating new benchmarks, the platform is very modular. So it's easy if you have your own benchmark suite already available. It's easy to integrate that in the whole platform. That'd be one option. The other option is that you provide actual traces, so query traces of the database system. And we have a system in place that is able to replay these traces as benchmark, but also to synthesizing the data in order to extend the traces and include anomalies in the traces. So for example, double the execution of query type X for 10 times or something like this. We also had a paper on that concept last edition of the ICPE. It was called the BUSY approach, where we presented this idea. Yeah. So these are basically the two options if customers want to include their own benchmarks or their own data, so to say. But it's also, of course, always a bit of a trade-off. So if the customers are willing to provide such traces, of course they're going to share actual data with us. And if they only rely on synthetic benchmarks such as YCSB or the TPC or any other, of course it's less effort from their side. But yeah, always depends on the kind of use case the customers are targeting. If they want to have a first base or first level comparison of different technologies, different resources, or if they want to go in-depth benchmarking of, for example, an existing solution that they're already they have already in place in order to find out the optimal configuration, then of course real trace-based benchmarking would make more sense. Yeah, so one interesting aspect that we found out in that study as well was regarding IONOS, where you can select between HDD and SSD storage. So they call it like that. And we assume they don't use any real HDDs anymore. But interesting thing was that if we look at the throughput numbers, for the HDD, we got around 11,000. And if we look at the SSD, we only got 7,200, which was rather interesting. And it turned out that we started the virtual machines with 100 gigabyte disk size, and they're actually throttling the SSDs depending on the size of the that you apply for your virtual machine. So if we use SSD with higher disk sizes, performance significantly increases. So that was a rather interesting insight, that if you don't need that much disk size, you can find a real sweet spot regarding the price if you just use the HDDs, and you will get even better performance.
One quick question on that, does this report or some other means of comparing cost of ownership or cost for performance, those kind of metrics, or it's just performance?
So we have costs. So the actual for the costs that we currently consider are the costs for operating the virtual machines. So in these costs, there is not included, for example, the database license. Not yet. What we also have when it comes to costs is for database as a service benchmarking, of course, the costs for then it's the full running the full database system on the cloud resources as costs. But we don't have licensing costs included so far.
Okay, got it. Thanks.
All right. Yes, so that was basically also one interesting insight. What we also did is, as already said, doing this version benchmarking or version monitoring of different database systems. So unfortunately, David isn't here because we did that also for MongoDB. And so here the interesting aspect was that if we look at the performance numbers, so what we did, we used the minor releases from 3.4 to, yeah, we did it to 4.4 in that data set. We also have the latest 4.6 and 5.0 results available, but not yet in that data set. And yeah, it turned out that the best performance was actually delivered when it comes to throughput was delivered with a 3.4 version. So 4.2 has the lowest performance, and it got better again with 4.4, which was, yeah, rather interesting that, yeah, you will not always get the best performance with the latest release.
Maybe you can ask David in the channel if that's consistent with their own experience, because that's kind of his day-to-day work. So I wonder whether that's consistent with.
Yeah, so
I
actually
suspect not. I suspect they will not be happy about seeing that.
well, they more or less stated the same in their when David presented the paper on their performance regression testing framework, because that was actually the motivation behind it. But of course, it would be really interesting to have his feedback if with these minor versions, if they experienced something like that with their performance testing framework. Yeah, so also again, when it comes to the latencies, you see also differences between the different versions. Of course, the same goes not only for MongoDB but also for other database systems where we did that. Yeah, latest version is not necessarily better performance. But of course, you will get new features, new security stuff, new query functionality, and so on, but not necessarily also better performance.
Hey, one quick question. Probably I might have missed this in the first hour. So when you say throughput or latency, what does that actually means? Like, do you run bunch of queries and then take an average, or I might have missed that? Can you please?
Yeah. So our platform actually applies different kind of benchmarks that are out there, coming from industry or research, and the results that you see here, we use the Yahoo Cloud Serving benchmark that runs a set of predefined or configurable queries. So the workload of the Yahoo Cloud Serving benchmark is pretty simple. It's a mix of create, write, update, delete operations, and then the operations per second are measured. And of course, yeah, averaged over each second. And then you will also get the latency metrics out of it. So the average latency, percentiles of the latency, how long each operation takes to be processed by the database. And latency is distinguished between the different kind of latencies depending on the operations that were executed. The workload that we applied for this case study was a write-heavy workload, so kind of IoT-driven workload with a 80% write operations and 20% read operations.
Okay, got it. Thanks.
All right, and of course, if you would run another benchmark as selected in the configurator, so for example the TPCC benchmark, you will only get this one TPC transactions per minute metric, and not necessarily the latency metric. So it always depends on the selected benchmarks what kind of metrics you will get out.
Okay, got it.
Okay, yeah, I think that's what we wanted to show regarding the results or the insights. And yeah, if there are there any more questions regarding the dashboard or the results that I've shown so far?
When I log in, I see this like new benchmark and free benchmark. So what does that, like free benchmark means like there is some limited set of configuration available. A new benchmark will have all.
Yeah, exactly. So the free benchmark is every user has a set of I think 3 configurations for free. And new benchmark would be you actually buy one of these packages that are available. So the starter up to the enterprise. And with these packages, you will get way more configuration options, yeah, larger cluster sizes, more resources, and so on.
Okay, thanks.
For as of now, you can pick any of the packages. Also, the large one we will not charge you. So just try it out using the big package if you want.
Okay, I just need to name it as spec or something. Am I right?
Spec or ICP or whatever, ICP or whatever.
Okay.
It's clear that this is because of the demo.
Okay, thanks. Do you expose hardware counters, or is it only for this ARM with CPU? At what level you will expose perf metrics from the underlying OS or hardware?
That's a good point. So what we currently expose is the time series of each benchmark run with respect to the performance metrics. So these are the performance metrics over the benchmark runtime. We also have the system metrics. So of course, we monitor everything. So we have a lot of operating system metrics when it comes to CPU usage, disk usage, memory, and so on. This is right now, it's not yet integrated into the dashboard, but in the beta version that's going to be released soon, you will also have the system metrics all available, and also database specific metrics. And what you can get, as Jörg already said, the metadata. So here you will get a lot of metadata on the actual virtual machines that are used. So BIOS version, BIOS vendor, also what kind of hypervisor, if that's exposed by the cloud provider. That of course depends on the metadata that the cloud provider exposes. So this metadata is already available.
All right, great, thanks.
Great. Yeah. So are there any more questions?
I'd like to ask about the idea of bring your own cloud or bring your own infrastructure as a service. Because here it seems that I could even prepare the benchmark, plan the benchmark using, there could be a way in which I could provide my own instances. So even if you don't have an API to drive the provisioning, I could give you a list of instances, or maybe expose an API in which I could still use your tool, but point towards my own infrastructure.
Yeah, actually, that good point. So that's also something that we're currently working on to enable to bring your own infrastructure on different. There are different options. So there will be the option to include in the configurator just your own list of endpoints that can be addressed in the benchmark process. So just the endpoint of the database system. Then there is the option to deploy the benchmark suite somewhere in the cloud or also on your resources to run the benchmarks. That's a feature that is also coming with the beta version, and we're currently working on that. Yeah. That's also something that several of our customers are asking for, to run these on premise. What we already can do is basically integrate any OpenStack based cloud private cloud installation in our framework. But if there is no cloud API on OpenStack or VMware basis, there's then still the option to just provide the endpoints and then use the framework.
Okay, another question that goes a bit out of scope, so feel free to either go in depth on that or not. But have you looked at how could it be possible? Let's say I have an event-driven system, and I could, how could I get from real recorded production data and turn that into a benchmark? In other words, not using your currently existing custom settings for a benchmark, but convert from my business events into something that can be turned into a benchmark, which I could use with your tool.
Perfect question. We did done that and presented a paper on that in the last ICPE edition, where we actually describe how customer data or traces of the production system of a database system can be applied to a custom benchmark that is also be customizable in the terms of injecting anomalies in these traces or extending these traces to based on customization options. I think Jörg, can you share the link to the paper in the channel to the tutorial?
Yeah, will do.
Perfect, thanks. Yeah, and there you will find. Sorry.
That would be awesome.
Sure. Happy to share that. And these concepts that are presented in the paper are also currently implemented in the platform for the next one of the next releases. Yeah. So, and we plan to also publish these results in another research paper that we get out of the current implementation.
Oh, thank you.
Yeah, you're welcome. Any more questions? If that's not the case, I think Jörg, then we just forgot. I will also share a link to a very quick questionnaire regarding the usage of the platform, and we would be very happy if you could fill out the questionnaire. That would really help us to see how you experience the using the platform. I will also share that in the channel. And apart from that, Jörg, I think then I can hand over again to you and the outlook and the preparation of the data challenge.
Yeah, happy to take over. So we're almost through. So we will definitely not need the 3 hours for this tutorial. Here's what I'm going to do next is just a brief, say, wrap up or outlook on what we're currently doing and where we want to go in order to engage with research. So currently we're working on what we call database performance ranking. That's okay. My trick for hiding the names did not work really well. So I messed that up. Actually, I didn't want to unveil any names yet. So what we're currently working on is like preparing this publicly available data set where we benchmark a larger number of databases in various configurations over several cloud providers with different workload intensities and different workload types. Currently, we have like 40 43-44 results available, and this is going to grow over the next couple of weeks and months. And an initial version of that will go live on 19th of April, so that's like 1 week from now. I'm currently tweaking the design, finishing up the first batch of benchmarks here. And the goal of this performance database ranking is of course, it's a marketing kind of instrument for us. But in addition to that, we will make available the data, the benchmark data, the traces, and all the logs, all the resource consumption data as an open data set, so that people can look at that and analyze this data set differently than we do, because our focus is on the benchmarking so far, and not on the in-depth analysis of the results. So if people want to take that data and find out things that we have not looked into, that we haven't seen, that we would very appreciate that a lot. Again, it's sad that David isn't here, because MongoDB is not really performing that good in that table, at least from the current results that we have, which may be because we have chosen a very weak consistency settings in the benchmark. So it would be interesting to see what he thinks and what he says about it. Right, so that's the one part. And as said, we're going to release the data set publicly, also for analysis by other research groups. The other part is that we would also like to share other data sets that we currently have with research. Of course, we cannot make them all publicly available as a default, but we're very happy to collaborate with research groups and with universities, and in order to do some research projects on the dataset to think about, or to work on analysis that we have not done so far. This may include, and that's a list of things that we can think of, but I'm pretty sure there are others. Noisy neighbor or interference detection, detection of bottlenecks in current configurations. So all that goes. Currently, we're very descriptive. We say in that configuration, we see that things are slow, but everything that can help us to grow from this descriptive analysis to insights. This is slow because that's what we're very interested in. Other things that would be cool working on from our side is predicting the performance of a specific configuration. So currently, we measure all the data, all the points that we have, and see how they perform. But it would be cool to have some sort of prediction mechanism, so that we do not have to measure everything, but we can reliably predict at least a subset of the entire space. And what's maybe on the same page is optimizer configuration. So if you have a bottleneck detection and you say this is slow because, and you have a performance prediction, you would possibly be able to suggest better configuration points than the one that you currently have. But I'm pretty sure there are many more options what you can do with our data, and we're very open here to collaborate with researchers all over the world on interesting ideas. So if you have ideas, please just get in touch. That's the one part. The other part is we're pretty sure that we can do a lot of other things with our tooling. So simple thought is that we can not only benchmark databases, but we probably can also benchmark other parts or other IT systems. One thing might be file systems, which is very obvious because it's very close to databases, but I'm pretty sure there are also aspects that might be worth looking into. All this AI stuff may require some GPU benchmarking, but I'm pretty sure there are other things. If you have ideas here, we're happy also to collaborate on that. We could provide, for instance, the automation parts of our framework to integrate other kinds of benchmarks from your end. And finally, we are thinking of, and Philip, it's cool that you're here. We are thinking, or we're wondering if it would make sense to provide data sets that we have to a data challenge similar to one MongoDB did this year. Our data set currently is not that big, but I mean, not as David's data set is, but by the end of the year or by autumn, we will have significantly increased it. So it might be something that the ICP wants to consider for next year. Right. That's pretty much it from our side, I guess. Yes, as said, we are always looking for pilot projects and research collaboration. So, and if you feel that this is something that that's interesting to you, please get in touch. And thanks for being here in the session. And thanks for your feedback and the discussions. And if there are some final questions, remarks, or suggestions, we're happy to hear them. Thank you.
Thank you for the tutorial.
Okay, one final question. Is that you might be extending that to other benchmark. Is there any plan for like Lambda or function as a service or comparing containers, such kind of things?
Absolutely. We have a rather huge list of things that we might look into. We currently don't have the capacity to implement all of that.
Yeah.
So for us, the question is where do we want to move next, and can we find collaborators that help us? So for instance, we have this tooling, we have this framework, but we have no idea about serverless benchmarking. So if there's anyone out there that is experienced in that field and that wants to like rely on the framework that we have, then I'm pretty certain that we can find a cool way to collaborate. Or same goes for other domains and other aspects.
Okay. There was a presentation yesterday in one of the workshop from University of Washington research students. They have some framework. I'll post that in the link in the Slack chat, and they have some framework to the comparison. But I think it might benefit if both can be and can work together.
Thank you.
So, since you're already kind of engaged in the spec research group, an obvious way is to look at the serverless working group within spec, because they have actually built a serverless benchmarking tool over the last couple of years and recently submitted a major publication on this.
That's the teapot thing, right?
No, not the teapot.
T-store. What is it called?
No, this is yet another research group, I think. So I'm talking about the serverless, not the microservice bench. So there is a microservice research group, and they do the teapot thing. And there's a serverless group that does a very specific for serverless kind of project. My feeling from looking at the presentation is, so unfortunately, Joel, who leads that activity, could not be here today, but I'm sure he will watch the video. My feeling is a little bit that the challenge for collaboration with that group might be that they kind of did solve a similar problem. So they have also spent a lot of time kind of on the automation part. So it might be that it's not, that you kind of not, that the solutions aren't particularly complementary, but more, kind of trying to address the same sort of problem, or not the same problem, but you know what I mean. But yeah, maybe listening in on one of their kind of monthly calls would also be quite interesting for you.
Okay, that's.
I think it's a little bit dormant at the moment because Joel is kind of wrapping up his dissertation, but I'm sure that activity will kind of spring into life sooner or later again because Alexandru also is pushing it very hard.
Okay, that's certainly something we should look into. Yeah, thank you.
Yeah, and about the data challenge, I mean, it sounds like a great idea. You need to talk to the PC chairs from next year, and if they want to run the data challenge back or not. I think it worked very well this year, but probably best to talk to next year's PC chairs.
Okay.
And they're already selected, so if you ask the steering committee, they can already give you the details of who is going to organize it next year.
So this year's went well, you said. So people were.
I think it went well for kind of a first-time pilot project thing. One thing that I think we learned, and that I think is probably a general lesson learned for this kind of projects, is that you want to think about the deadlines and sync your deadlines up with kind of the academic cycle, so that your data is available when, at the universities where you hope people are working on this, it syncs with the kind of master project cycle. Because one problem that we had this year, for instance, is that it kind of fell outside of the cycles for when people actually write their master thesis and do their kind of research projects or the things, and then it's not so clear who the target audience actually is. So you might want to identify which groups or which universities are most likely to submit to your data challenge, and then get in touch with them and ask, okay, when do people actually start their master thesis? Because I think in Germany it's fairly flexible, at least in Austria it is. But for instance, in Sweden there are exactly 2 dates where students are allowed to start their thesis, and then they work 4 months from these dates. And if your data is not available there, people aren't working on it.
That's a good point. Yeah, that's good. But I always found the Swedish system very, very not difficult, but it's substantially different from the German.
Oh, it is very, very different. But the thing is also, I think the Swedish model is internationally the more common one.
Yeah,
where things tend to be more regulated.
Probably,
not always regulated in the same way as in Sweden, but I think Germany is unusually flexible in a lot of things.
For once. Okay, guys.
Anyway, good.
Thank you very much for staying with us. It was a pleasure. Also, thank you for the discussion that we have had, and I'm looking forward to this week of ICP.
All right. Thank you.
Bye.
Thank you
Thank you, guys.